Hey, I'm William. Today we're rolling up our sleeves to find out why our Maytag washer isn't spinning or agitating. A bunch of things including a bad belt drive, a motor, a capacitor, a wire harness, a shift actuator, a lid lock, or main control can cause this to happen. Before we get started, hit those like and subscribe buttons if you want to join our do-it-yourself repair community and get notified each time we post a new video guide. With over 2 million products in stock and the know-how to help you do it yourself, we are AppliancePartsPros.com. Today we'll need a multimeter, a flathead screwdriver, a 5/16 inch socket, and a 1/4 inch nut driver. While you're getting those together, remember to keep safety first. Always unplug your appliance before you do any work on it to protect yourself from electric shock, which can potentially cause serious injuries. Don't forget to turn off your water supply and unscrew your hoses from the washer. You might need a towel handy to clean up any unwanted water. Before we really dig in, let's check a part that can easily fail from normal wear and tear. That is the drive belt. To get there, we can lean the washer back. I'm setting the washer on its back so you can easily see what I am doing. We're going to grab a 5/16 inch socket to remove the belt shield bolts, and after we do that, we can set the shield off to the side. Now we can check the belt to see if it's broken or if it's stretched out. You shouldn't be able to pull the belt in very much when pinching the belt in between the pulleys. If the belt is damaged or fails testing, it'll need to be replaced. If the belt is good, we need to continue troubleshooting. Since we're already here, let's test the motor. First, we can remove the belt, then rotate the motor pulley to see if it moves freely. If it doesn't, that means the motor has failed. If it does rotate freely, we'll need to test the windings. We're removing the wires to isolate the motor. Now we're taking our multimeter and setting it to ohms, which has a symbol that looks like an upside down horseshoe. We're going to test from the white wired terminal to the other two terminals. That'll be the orange and the red. The windings should measure between 3.5 to 6 ohms. If the windings aren't within this range, then the motor has failed and needs to be replaced. If the windings test good, we can put the wire connection and belt back on and continue troubleshooting. Now we're going to test the capacitor. Before we set our meter, we're going to carefully disconnect the wires and use our screwdriver to discharge the capacitor. Do not touch the metal of the screwdriver. We're going to set the tip on one terminal post and create a bridge to the other one, then leave the screwdriver there for a few seconds. Repeat this one time. Now that we've made sure the capacitor is discharged, we're setting our meter to capacitance, which has a symbol that looks like 2 sideways T's facing each other. Set your meter probes onto each post. If the capacitor is good, we should get a reading between 48 to 52 microfarads of capacitance. If the reading is outside of this range, the capacitor will need to be replaced. If the reading is good, we can plug the wires back in, install the belt shield, and set the washer onto its base and do some more troubleshooting. With most parts tested already, we're going to jump into voltage testing at the main control. And to do that, we'll need the washer's power on, so please be very careful here. Always take extreme care when checking live voltage so you can protect yourself from electric shock, which has the potential to cause serious injuries. Don't ever test live voltage if you're uncomfortable using a multimeter. We're going to grab the 1/4 inch nut driver and remove the screws from the rear console cover. Using our tech sheet, we're going to set the washer into diagnostic mode and select the tachometer test. We also need to set our meter to DC voltage, which looks like a V with a solid and dotted line, and locate the J2 connector. We're testing from pin 3 with a black meter probe to pin 4 with the red probe. We're looking for 13 volts DC. If there's no voltage present, then the main control has failed. If you do see voltage here, we can move the red probe to terminal 2. With both our probes in place, we're rotating the basket by hand and we're looking for a return voltage. If we have a return voltage, the main control might be the problem, but we need to test further to see if there is another part that has failed. If there isn't any return voltage, we need to continue troubleshooting. The test we did with the main control is the same for the shift actuator, but if we had 13 volts DC from the wires at pin 3 and pin 4, but no return voltage from the wires at pin 2 and pin 4, then the shift actuator has failed and will need to be replaced. If you got return voltage, then the shift actuator is good and we can continue testing. We're going to cancel out of the tachometer test by pressing the cancel button and holding it down for 3 seconds, or unplugging the power cord, and then plugging it back in. Now we're going back into diagnostic mode and selecting the manual test option. With this done, we're going to set our meter to volts AC, which looks like a V with a squiggly line, and testing the connection J15 from the yellow wire at pin 1 to the white wire at pin 3 for 120 volts AC. When we press start, we should see 120 volts and hear the lid lock. If the voltage was measured but the lid didn't lock, as we see here, then the lid lock assembly has failed. If the lid is locked, then we can press start again for it to unlock. Now we're going to cancel the test mode by unplugging the power cord so we can do some more troubleshooting. This is our last step, and we're going to see if the wire harness is the problem. Since we already tested the motor windings directly, we can test the motor circuit from the main control connection J16 to see if the wires to the motor are good. To do this, we need to set the meter to ohms and remove the J16 wire connector. With the black meter probe on the white wire from pin 5, the red probe is going to be set on the red wire and then the orange wire to see what resistance we get. If both wires give us a resistance between 3.5 to 6 ohms each, then the wire harness on the motor circuit is good. If you have reached this point without finding another bad part, then the main control needs to be replaced. If you don't get good resistance when checking the motor circuit, then the wire harness needs to be replaced. Once you're finished, lift the panel up and put it back into position. Then grab your 1/4-inch nut driver and put the 6 screws back to hold the top back panel into place. Don't forget to plug your washer back in, turn your water supply back on, and screw your water hoses back into the washer. You made it! Great job! We hope you were able to find the part that failed in your washer. If you need a replacement, visit AppliancePartsPros.com with your model number so you can order one. You'll most likely have the new part in your hands within a few business days, and we have thousands more videos like this one to guide you through the installation process. We'd also love to hear how your repair went, so share your story in the comments. And don't forget to hit those like and subscribe buttons to see more of these videos. See you next time.